So since there's not that many of you, if you want to just ask questions in the middle, feel free. Oh, hey, what's going on?
What's an SBOM?
Oh, I'm going to get to that.
Great.
So an SBOM is a software bill of materials. The TLDR on that is it basically just tells you what are the building blocks of your software. And people talk about them now because they're in executive orders. There's a lot of compliance reasons for having these. But they don't actually do the thing that you think they do. Or they don't do the thing that's actually useful. So I'm going to be talking about software bills of behaviors. And this is more about what is the software you're using actually going to do if you use it. The way I think about this is every day, basically every second. Right now, I'm using software that I don't really understand. We all do it. We all have this trusted software. And what would be really useful to have is a bill of behaviors that'll tell you what is this software, what will it do, and ultimately say, is this bad? Is it going to hurt me? The TLDR, there's a lot of software supply chain attacks out there. They keep getting more prevalent. They keep getting worse. And the problem is SBOM doesn't actually solve a lot of these things. It's been proposed as the solution, but it does a thing, and it's OK at what it's supposed to do, but it's not a panacea. But what a software bill of software bill of behaviors would give you is it actually gives you control over your software supply chain. It gives you understanding of what your software will do. Now, should you listen to me? Whatever, I don't care. But you're here, so you might as well. At least take 50 minutes of your life and listen to me for a little bit. I have been doing cyber for a relative while. I have a little bit gray in my beard, not a full gray beard yet. But one day I will be. But I've been doing a variety of fun problems in this space. I've done a lot of offensive and defensive cybersecurity. So finding bugs, automatically exploiting them, RE, adding in data science, all around this kind of stuff. And I'm the co-founder of Karambit AI. It's a startup doing automated reversing for software supply chain security, which is somewhat related to this talk, but not really. That's not what I'm not here to talk about my company. I'm here to hopefully expand the conversation around what software supply chain really needs to be, and hopefully more what cyber in general could be. So if you want to talk after this, please do. And I'm really easy to find on LinkedIn. I'm the only Andrew Hendela in the world, so you're going to be able to find me. So why am I talking about this? I mean, the big reason why a lot of people talk about this is the SolarWinds attack. It happened. It basically popped everybody. And it did this because of trust. People trusted the SolarWinds company. They trusted that software. They let it in. But the Russians had already hacked them and put some malware in there. And as someone who has done offensive cyber, this is actually a really beautiful attack if you actually get deep into what actually happened. The attackers didn't put anything bad in the source code because people do source code scanning. They check, they make sure. They put it after the source code during the build process so that the thing that came out, the thing that was trusted, the thing that came from the right place had malware in it. And they thought, OK, well, once it gets to the other side, what are they going to do? Well, they're going to check the signature. OK, check the signature, came from the right place. This is perfect. OK, we'll do a little testing. Most people only test for about 14 days. So the attackers, of course, just literally put in a wait, 14 days. OK, now you've done all your testing. Now you trust it. Oh, what's it doing now? Oh, it's sending out to, I think it was AVS Cloud. So kind of looks like AWS. Maybe that domain looks fine. And they were able to compromise basically all the people they really cared about. 18,000 organizations, basically every US agency you care about. They got Microsoft. They got, I think, 425 of the Fortune 500, maybe. At least that used to be on the SolarWinds website. Then they took it down. They only got caught because they actually hacked FireEye. And FireEye was like, oh, this is suspicious. And then they did their remediation and found, oh, hey, we got this. Chain of events. Now everyone realized they got hacked. So this is the big one. This is why I started thinking about this. But then again, we had another one a couple months ago, the 3CX attack. This one was actually interesting for a different reason. Before it was Russia, so kind of like if you're thinking cyber threat actors, probably Russia's a little bit higher than DPRK, like North Korea. North Korea usually is just trying to steal money because it's one of the only ways they can actually get funding for their government at this point, at least externally. But what's interesting is this was a chain software supply chain attack where 3CX itself got compromised because their software supply chain was compromised. They pulled it in, then they had some malware at them. I think, the numbers are a little confusing, somewhere between 200,000 and 600,000 organizations. And again, they got to opportunistically choose, who do I actually want to compromise here? And this is why it's so significant, is because once something in your software supply chain gets compromised, they get to pick and choose. Maybe you're not a target, but maybe you are. Maybe you're the thing they actually care about. In this case, crypto companies. But those are nation state level. Like, oh, well, why would I care about this? I'm not a target from nation states. PyTorch, well-known Python library for AI. This also got compromised. And this one, this was done by a dependency confusion attack by an ostensible security researcher, where they added in a compiled binary to a Python library that was used internally by PyTorch. Oh, that was loud. By PyTorch. And they found out about it, so they said, oh, well, I'll just go into PyPy, make that a new library. It had malware in it, got naturally just pulled in automatically. And this was right at the end of December, so probably a pretty good time to do one of these attacks because, oh, hey, people are on vacation, maybe it'll slip in. Thankfully, it didn't. But I think the key point I want to bring up here is this was just some person. It wasn't a nation state. It was just some guy who said, OK, well, let me see if I can get in. Let me see if I can steal some data. They got caught pretty quickly, but the bar is incredibly low for these kinds of attacks. And they're getting more prevalent, and in some sense, both more and less sophisticated. Because you don't have to be a sophisticated attacker to do this. And I wasn't going to talk about all the malware that's on basically every app store. But last month, this attack happened where it was actually a legitimate app for a year. Just there, got 50,000 downloads. And then I guess the developer, someone decided, oh, I'm going to switch it up. So now it's going to start doing file exfiltration. It's going to start recording audio. So the point here is there's a trust problem. And it's not, you can't just verify that trust once. You have to think continually. And as with every other security problem, it's going to be taken advantage of. And the way Microsoft talks about this is trust is explicit in the software supply chain, like all the other supply chains that people care about now ever since the pandemic and things broke. And I got asked at one point, oh, okay, I understand the physical supply chain. What is the software supply chain? And if you don't understand that, it's basically like every bit of software that we all use gets pulled in, things from all over the place. It's not just one person who develops all of it. I was that one guy who raised his hand when I said, oh yeah, I read the Reflections on Trusting Trust. Yeah, it was that guy. Because this is just incredibly fascinating. There's all kinds of things that we trust. The TLDR of Reflections on Trusting Trust is there is trust everywhere in software. You write that code yourself. You know the thing you didn't write? The compiler. So if somebody gets into the compiler, hey, it can always send out the right thing until you say you want to do authentication, and then it just tweaks it and adds a backdoor. And you wouldn't know because even the source code for that compiler might not show that. It might just be in the binary. And that's really the thing. Everything we do in cyber, everything we do in software is about trust. And the defense is going to work in this trusted environment. But the core of this problem really comes down to information. We need the right information to make decisions. And right now what we have is a lot of data. We get software suppliers to say, oh, check these boxes, fill out these questionnaires. Hey, are you doing the right cybery things? But again, it's checkboxes. And you may get checkboxes usually once a year, sometimes not even that often. It depends on how critical these suppliers are. But this is only for commercial software. If you have open source, it's a completely different thing. Where you'll have new libraries, you'll pull them in. Oh, hey, the Docker image, I just pulled it in. What's it going to do? Oh, I'll trust it. Oh, but there's been plenty of times when crypto miners or exfiltration or all kinds of things happen. Crypto miners, at least, those are really easy to catch on the back end because it's like, oh, this is really loud. It's doing some weird stuff. It's using the GPU when it never did. OK, let's stop that. But what about something that's going to be a little bit more subtle? What if it's just slowly taking out data? So we need to think about this better. We need to think about trust. So right now, there's a lot of different frameworks talking about supply chain security. This one is a picture from Google's Salsa, supply chain levels for software artifacts. But I like this because it's helpful for describing the different kinds of attacks that can happen and the places just within the software development lifecycle that can be compromised. And honestly, it's a lot. You know, we have all the way from A to H here. You can go from developers. The developer obviously can be compromised. There can be an insider threat. The source code repo can be compromised, all the way to the software that's about to be sent to consumers, let alone the dependencies, which, again, that's the software supply chain in a nutshell. You have all of these things. You have all these places. But to stop these attacks, there's this focus on, hey, let's scan the source code. But if something bypasses the source code, you're not going to be able to find it. And even if it's in the source code, you're not going to necessarily know what that source code is meant to do. This really ignores all those attacks that the attacker can do by hitting the build system, hitting the package manager, hitting dependencies. So ultimately, you need to check everything. And right now, the defensive focus isn't enough for this. There's, hey, we're going to look at SBOMs. We're going to figure out, hey, what are our known vulnerabilities? We're going to see, something like Vex, where they're going to say, hey, let's message about whether this vulnerability is actually exploitable or not. Which, I mean, these are all actually really good things. But the thing is, if malware gets put in, that's not a vulnerability. That's a malicious behavior. And when something like this happens, really, when this gets detected, it's post-compromise analysis. So now you have to do your remediation. Now you have to figure out, oh, what happened? And that's not going to be ideal. You want to get this sooner. And SBOM doesn't actually do this. All it does is say, hey, what are the components inside of this piece of software? Again, I'm not going to say this is a bad thing to understand. It's just not enough. We need to do more. We need that visibility that SBOM can provide, but we need to understand what that actually means. The analogy I like to use is this list of ingredients here. Hey, there's aluminum phosphate. Do you know if that's good or not? I don't know. I mean, at least down here, you can see it says contains milk and wheat. So at least if you're allergic to something, you can say, oh, well, I know that's bad, at least for me individually. But with SBOMs, it's basically the same thing. You're not going to go through and read this. You might do it to check a box. That's a lot of the reasons people do it. It's like, oh, there's an executive order, right? It makes it sort of almost necessary for government contracting. So you check a box, SBOMs, and then you send it off. And then the people on the other side basically have the same problem. OK, what do I do with this? Is the end user going to read it? No. They're going to probably store it somewhere, maybe check it. Maybe if they're forced to, they'll do something. Most of the time, the use cases around this are vulnerabilities, known vulnerabilities or known malware. And there's a bunch of open source things that'll basically tell you. So you can go to deps.dev. You can map this back to scoring systems and then prioritize. And then you get the recommendation, oh, well, just patch everything anyway. It doesn't matter. It doesn't matter what your scoring system is if someone is just going to say, hey, patch everything. So, and then you don't because you don't have time. You have all these other limitations, right? And what it comes down to is what we need is to understand these limitations. I kind of mentioned this already. Hey, this contains milk and wheat. You have to understand something about the ingredients to make them useful. But it also needs to be trustworthy. If you're getting this from a supplier, well, how do you know it's actually the thing that's expected? I heard this particularly terrible joke because it's terrible because I thought it wasn't a joke at first. And I'm not going to say who the company the joke was about. But it was basically like, oh, hey, this major company sent their SBOM to their customer, and they scanned it and they said, oh, there's no vulnerabilities. Good job, good job. And it turned out, oh, well, what actually happened was an intern had added company names, so Karambit, in front of every open source package they had. So the names were Karambit OpenSSL. Oh, well, Karambit OpenSSL has no vulnerabilities, so we're fine, right? And that really just shows the fragility of this system. if a developer forks the open source software, those public databases of vulnerabilities are going to be less useful. You're not going to be able to do with them what you think you can. And the other thing is, it might actually not be legitimate anymore anyway. If you've forked open source and you've patched those vulns, well, yeah, of course, it's fine, actually. But you won't know. It's kind of like the malicious version of FFmpeg that was used in the 3CX attack. They added this malicious open source library in. They took it, they recompiled it, they added their malware in. If someone actually checked for that particular version of FFmpeg, it's going to say it's legitimate. It's going to say it's fine, just because, oh, it had the right, hey, I claim it's the right version number, I claim it's the right thing, but it had malware in it. Because, again, this isn't about, a lot of these software supply chain attacks aren't about vulnerabilities. They're about the behaviors. And I think the final thing, coming back to trust, because you have to trust somebody, a developer can only tell you what they know about. So you see this at the bottom, right? Hey, this contains milk and wheat. And this part of the analogy I actually got a few months ago from, it's actually a Richmond local company called Absurd Foods, and they're focused particularly on making foods that are allergen-free. And they do their production in a place that has no other allergens whatsoever. But that's exactly the point, because, hey, this contains milk and wheat, but if somebody accidentally slips in some peanuts, somebody with a peanut allergy needs to know about it, but they won't. In the same way for an SBOM, if somebody's sneaking something in, you have to know about it. You have to double check. You have to trust yet verify. And ultimately, that's the thing. We don't actually know what we don't know. And it's easy for attackers to hide in any number of places. But I think that's honestly the fun part about cyber. We get to test ourselves against another human who is really good at what they do. They want to get in, and some of us want to stop them. I mean, for the people who do pen testing, they also want to get in. But we get to have that challenge, and we get to learn, we get to adapt. And hopefully, we get to win, as long as we don't get tired and burnt out like apparently everyone does. But ultimately, what an SBOM is, it's all about risk mitigation. You want to tell you something very simple. You want to get enough information to know if this software is trustworthy. That's what risk mitigation is about. That's ultimately what cyber is about. Can I trust this thing? Should I let it have my data? Should I allow it on my network? Will this software actually cause me problems? And that's honestly why I'm talking about a software bill of behaviors. Because while SBOMs don't do much, they are a baseline understanding of software building blocks. But we need something more than that. When someone downloads an app on their phone, right? You look at the permissions. Do you actually care about the permissions? Maybe a little bit. But the thing you actually care about is understanding, is this app going to do something bad if I give them those permissions? If I allow it to track my data, if I let it take my location data, I want to know, are they actually going to do something bad with it? That's the thing you really care about. And ultimately, do I care enough about that not to download it? So the billions of people with TikTok, right? That risk assessment was somewhere in there, right? And they said, let's download it anyway. But what we care is this data, right? Do we want my example, AV mining crypto, right? What's it going to steal? What's it going to take? Ultimately, right now, these things kind of get found out because someone does a deep dive. They said, oh, let's pull TikTok, let's rip it apart, let's do some manual analysis on it, because this thing is important. But we should and we can do better. But before I get into a little bit deeper about why we care about this, what is a behavior? Does anyone actually have an answer for this? What is a behavior? I'm asking this because I'm drinking. What do you want to say?
It's something that software does as opposed to what software claims to do.
I like that. I like that distinction. Oh, yeah. I think he wants me to repeat it.
I said what a software does rather than what it claims to do.
Yeah, in case no one heard that, it's what a software does as opposed to what a software claims to do. And I think that's That's pretty much what I was going to say. So thank you. It was perfect. And we kind of have like intended actions, right? The actions is something we'll take. And a lot of times it just comes down to inputs and outputs. That's usually what we get to see. You know, software being a black box, see what goes in, see what comes out. I mean, whenever you connect to an API, this is essentially what the developer will tell you. Hey, what's the input? What do you expect to get out of it? You don't care about the other stuff. And that's most of software development is actually predicated on this, that you don't care about the implementation. You just take the inputs, you get the outputs, and maybe you'll see something about the side effects. But from a security perspective, you need to know the implementation. The implementation, the actual things that are happening, those are the things you really care about. So you gotta take a deeper level and say, okay, what is the data use like? What are the network connections? What are all these attacky things, right? The attack TTPs, the MITRE attack TTPs. I'll get a little more formalized. These obviously all can be intended actions. And usually when people think about it, MITRE's attack, they're like, oh, well, those are TTPs, those are problems that attackers can use. But there is always a legitimate reason for any behavior that happens on a computer. Otherwise, the computer probably couldn't do it. Think about it, like, there's nothing that is inherently malicious or benign. But at the lower level, you can get to, okay, algorithms, data structures, all of the magic math that's underneath everything. But if you're talking to a supplier, I'm guessing they're probably going to be more likely to give you those top two. Maybe a MITRE attack TTP mapping for their software. Maybe the inputs and outputs, maybe the data use and network connections. But those are probably the things that we actually care about when we're doing cyber defense, more than the underlying transformations that might be happening. But again, it's not just intended actions, it's the unintended ones too. There's all kinds of behaviors that software can have that the developer didn't actually intend. I mean, obviously, coming back to the MITRE attack stuff, the malware type behaviors are probably the more obvious, right? Though most of the time, these are going to be intended by someone, just not the developer, again, hopefully. And I put this on both lists for that reason, again, because none of these actions is inherently malicious or benign. My favorite example of this is ransomware and full disk encryption. Full disk encryption, if your IT security person is telling you to do it, okay, then that action is fine. But if your computer is doing it on its own, or because you downloaded WannaCry accidentally, then you're going to have some problems. And it's that same behavior. And again, if a piece of software is, taking inbound connections from, external people, doing some sort of calculation, gathering data, and sending it back out, that could be a piece of malware doing C2, or it could be the web server. And sadly, the number of times I've seen alerts based on the web server doing web server actions, it's too high, we'll say. And then, of course, it's not just those kind of actions, but crashes. Crashes are another action, another behavior. Again, this probably shouldn't be intended, but if you can understand on a particular configuration, certain inputs, that's definitely a behavior you want to know about. I mean, not when you want, but when you want to know about. And then we have exploits, right? If you think about behaviors, yeah, so a SQL injection exploit kind of seems more in line with this, right? Like, oh, well, the SQL itself was intended, but the fact that it's a SQL injection probably wasn't intended. But even arbitrary code execution, like you build that from an overflow, whatever, it's still a behavior of the software. Again, probably not intended, super complicated, weird, actually. There's some formalized papers talking about weird machines, and it's basically talking about how you take a crash, you can turn it into an exploit, because now you're just working on ROP gadgets and all of these things. And it's a machine still. It's still a behavior of the software. And sadly, it's doing what the developer told it it's allowed to do, but you probably are never going to be able to get, once we get here, we're not going to be able to get a list of every single behavior for your software, because now you have arbitrary code execution, you're dealing with Turing machines again, you're not going to get there. But if we can't get all the behaviors, what can we get? The first one is, well, you can probably ask the vendor really politely, for some of this and get the intended bits of software, get the intended behaviors, right? They should have this information. It's not going to be formalized. But a combination of things like tickets or commits and translating that was going to make that possible. I'm going to say it's straightforward, probably isn't, but it's something that could potentially be done. And you could extend this to open source. That would definitely be another option. And this would be, I mean, it's pretty similar to patch notes. Patch notes right now are a very high-level understanding of software behaviors. Usually they're not good enough for this kind of thing, and sometimes they're not really good enough for even understanding what software has changed. But if you have source, you can, of course, build this from source. And I've seen some interesting work with LLMs, right? ChatGPT, taking source code, pulling it in. The analysis I've seen is pretty expensive to do this, but LLMs are really good at translating things. Like that's kind of their job. So take source code, translate it into the behaviors, and maybe that's another aspect of this. If you want to build them yourselves, ask ChatGPT, hey, what would my source code do? Similar idea, build this from binaries. Take that compiled software, either manually or automatically reverse engineer it, pull it apart, use some ML, right? And get some downstream processing on that. One of the things I've seen a lot in my years of doing automated reverse engineering is people will take binaries, like, oh, well, I'll just decompile them, and I'll use that source code, and I'll just use the regular source things. I don't know if anyone else has done any of that. They never work out nearly as well as you want them to, which is why usually when I'm doing this kind of stuff, we stick to the binaries, because that is what the software is going to do, because that's what the compiler has built. That is the thing that is going to run on whatever architecture you're running with. And finally, like we're talking about software bills of behaviors. I mean, these happen. The place that these actually exist right now is malware analysis, right? You throw things into a detonation chamber, you throw it into a sandbox, you see what happens. You record that, you do scalable analysis on it. There's all kinds of things. In some past lives, I've done a lot of that. But the main problem with those kinds of things is you're not going to find any of the rare or hidden behaviors because, again, you get 90% of the way of evading those things just by waiting. Just wait a couple days, wait an hour, put in some command line arguments, don't do anything. Oh, well, yeah. Hey, that software didn't do anything. You're fine. But ultimately, like, if you can build one of these things, why do you care? Why do any of us care about anything? Now I'm getting existential. Never mind. Let me keep going. But why do we care about behaviors of software? What is the practical use? And of course, this is
People can lie about what the program will do, and by its behavior, could see what it actually does.
that is one of the biggest use cases, honestly. This is the core of why it matters, because the biggest use case is people can lie about what their software is going to do, and they do it all the time. I mean, malware authors obviously aren't going to tell you all the bad stuff they're going to do, but there was this Mozilla study that basically said 80% of apps reviewed, Mozilla found that the labels were false or misleading based on discrepancies between the app's privacy policies and the information apps self-reported on Google's data safety form. So this isn't even like reverse engineering, right? This isn't even getting like deep down into it. This is just, hey, they said this thing to Google to go on the App Store, and then their privacy policies says something completely different. It's like, oh, yeah, we're going to take all your data, and we're going to do all this stuff with it, but we're just not going to tell you about it. Actually, this comes back to the thing, like, the thing you care about is, what are you actually going to do with my permissions? And I'm pretty sure everyone has looked at a privacy policy a little bit and been like, what does this actually mean, right? Maybe that's the real thing from ChatGPT. Every time you see a privacy policy, can you translate this into something that actually like will tell me something? Oh man, now I'm going to do that. But yeah, so those are some applications, but like this is probably something the developers aren't going to be telling you about, right? And I found when I found this article, when I read it originally, I found it really interesting. $20 per 100 unique users. Like that's actually not It doesn't seem like that much to me, or $2 if you're, I guess if you're not getting a lot of data. But there's all these companies that will pay developers of software to install their SDKs that will now add tracking abilities. And depending on the sophistication of the SDK, it may not actually even show up as a permission for tracking location. I remember reading an article about that, but I could not find it, but I really wanted to. But this would definitely be an example of why you'd want to build these kinds of things yourself, whether manually automated something. Like you have to understand yourself. You can't necessarily trust at least these developers. If you're a big enterprise and you have a little bit more, I don't know, I guess power in that relationship, you probably can get them to tell you something pretty well. But another example I really love is Norton Crypto, because this actually was intended functionality, not just intended functionality. It was functionality Norton added and wanted people to know about. Because their big thing was, hey, look, right on their website down here, here's the FAQ for Norton Crypto. Please use this. We want you to mine crypto on your machine when you're idle, and we want to take 15% of it. Like, we'll set it all up, and the quote was they wanted to enhance safety of crypto mining for their customers. Because obviously Norton's trustworthy, so if you're going to mine crypto, you don't want to download a random crypto thing that might steal your crypto. You want to get Norton to not steal it, to be clear. But what I found fascinating about this is it took, so this was like June 4th, 2021. It was about 7 months later that someone actually talked about it from the security community. It took 7 months to learn about a behavior that might be suspicious, or not, right? It's intended. But it took 7 months, even though they were talking about this, they wanted people to use it. And I think this really comes into, like, we have to have a better way of understanding behaviors, messaging about them, talking about them, figuring them out. Because right now, like, patch notes and press releases aren't really doing it. Another thing that would be really helpful to have, like a reason why we would want to understand behaviors is we get all kinds of updates on our machines all the time. Patch Tuesday, right? Like, was that a couple days ago? Is that today? I don't know. Who knows? I probably have I have an update on my phone, on my computer. Oh, well, oops. I'm not even doing this myself, right? I'm not even patching my stuff. But understanding the benign software that's on your network would be incredibly helpful, because alert fatigue sucks. I don't know if anyone's like done SOC stuff, but like ding, ding, ding. Oh man, is this malicious? Oh, of course it's not. It's another false positive. And you have to enrich it. You have to get all this understanding. If you actually understood what the software was meant to do from your benign software, and you can just take that, automatically tune your algorithms, and that would save so much time. That would save so much of burnout, so much people's lives. But part of this is, okay, you need to understand what the software is, and you need to be able to ask your vendors, hey, you got a new update. Is it going to do something suspicious? Because, hey, it's going to connect to a new server. It's got a new IP address. And I think one of the key parts of this is, as anyone who has lived in a SOC knows, new or anomalous rarely actually means malicious. So being able to remove some of those false positives would be awesome. So here's an example of a MITRE attack technique that will always seem suspicious to me. Creating a reverse shell. Would anyone like to guess what thing on most of our computers here does this? What? No, not a reverse shell, but that's a good one. That's actually more like my other example. I'm not going to show it, but there's a paper that was written called "The Advanced Persistent Threat You Have," and it was basically talking about how Google Chrome's auto updater is malware, or at least it seems like it, right? It does all of those behaviors. This one, what was that?
It's like network. The thing that we do is network mounting.
Oh.
It's always a fun moment when you're just like logging in work, you see command prompt.
Network mounting.
Command just opens and closes immediately.
Network mounting. Oh man, yeah, that could be. No, so this is actually funny because it's actually really obvious if you think about it for a second. Putty, SSH, right? Like that is literally its job. Actually, Netcat would have been another option. Netcat is super weird. If you're ever doing like pen testing, like Netcat is like a gold mine for being able to get short amounts of characters into getting to a reverse shell, because there's a command line argument that basically says, hey, connect back to me and run this command. It's a beautiful thing. But this is on everybody, right? So the context is really important here. So if you have this software that, oh yeah, that's expected to do this, yeah, right here. So which brings us into unexpected behaviors. So we're talking about, oh, well, we want to be able to remove potential false positives. But if we actually have an understanding of what the software is meant to do, once it starts doing something else, then we can actually find it. So, hey, that crypto miner, okay, maybe this one is actually bad this time. Or, hey, there was an exploit. It's now connecting out. It's doing something it never expected to do. If you have a baseline, then you can see where it changes. And that can do so much. And the extrapolation of this is changes between updates, just understanding what is this software going to do. If you think about how much software is going to change over time, then you'll be able to see, oh, hey, they just added that tracker. Maybe they got paid the $20 for the 1,000 of us. And this way, you might actually be able to find, did this thing that was trusted get turned into malware? OK, so we're back to this example. And this is the one ESET found last month. It was an app that had 50,000 downloads. And it was later updated to add the capability of recording audio every 15 seconds. There was that change that should have caused a really big red flag. But it's also how attackers work. I mean, I'm not going to say like this particular Android app always intended to turn bad. But it's something that attackers will do to try and test defenses. They will say, OK, well, let's submit something. Let's see what happens. OK, and let's change it a little bit. Did I get through? Oh, perfect. Did I get through? Hey, maybe I can add a little bit more, just enough to be that stage 1, to get my stage 2 downloader down. Now you're compromised. In fact, this is actually something that happened in the SolarWinds attack. You can see here, they spent from September to November almost 2 months testing to see, hey, can I insert code in this build pipeline and not get caught? They spent 2 months doing that. So a few months later, when they actually put in the malware, they were very confident they were going to be able to get out. And then it went from, February all the way till December. So they had 10 months in some places. A very similar thing happened with the 3CX attack. It could have been noticed by just seeing how the difference between what was expected and how it behaved over time. Because, OK, they added in the capability to allocate read, write, execute memory, and some RC4 encryption and decryption. They added more functionality for that. So pretty good indication from these behaviors, there's an encrypted payload in here. So if you already expected to have these things, once the decrypted payload connected out to C2, it's much easier to find and stop that attack before it actually causes damage. So if you're going to get a software build behaviors from the developer, this would be very easy to find those and stop that before it actually causes problems. Now, I've been talking a lot about the malicious behaviors section, but there's also an entirely other aspect of behavior. When people are trying to update, when they're trying to update, a lot of times they're scared, right? We have this thing down here from EdgeScan that says 65 days is the mean time for remediation for critical severity vulnerabilities. That's a really long time. Whether that's padded or not, I don't know. But that's way more than the standard I've heard of 14 days of doing testing before setting a patch. But why do people do this? Well, according to the National Cybersecurity Centre, patching takes time and costs money, and it introduces risks. And the reason I'm quoting them, even though it feels obvious, is because there's another part of that blog post that I just want to quote because It's so succinct. For small companies, a failed patch rollout is painful. I think everyone understands that. But for large organizations, it can cause as much impact as a cyber attack, stop thousands of people from working, and require massive resources to fix. And it really comes back down to the trolley problem, if you know that from philosophy. Hey, do I pull this thing and kill one person, or let the trolley kill 5 people? So it's like, well, if I don't patch, if something bad happens, it's not really my fault. I didn't do anything. Just, we had a cyber attack. But if I patch and then everything goes down, now it's my fault. And it's the same sort of thing, right? But if you could actually get a better understanding of, hey, from your supplier, hey, if you have it in this particular configuration, this is the behavior that will happen. It'll crash. That's going to lower your risk and actually help the supplier as well. And I think this is probably the best argument for the suppliers to provide these, because no supplier wants to deal with a 3-year-old bit of software. They're going to get called more. They're going to have problems more. So if they could actually provide these and help you with that, I think that's probably the best argument. And what's interesting is this is some numbers from a Patch Tuesday analysis that we did internally for Karambit. And this is just an example. I pulled some /Windows binaries off our box, all the DLLs, all the executables, all the sys files. And there were about 3,600 of them. And no one actually is going to do the deep level of analysis that we did on these manually, because it would take you 3 years. So every month, spend 3 years. Probably not going to happen. But what we found is 90% of the time, software doesn't really change all that much. You get an update, and it's not actually going to do much. So a lot of this FUD around updates, it's just that. And I think, that's why I really talked about the trolley problem. I think that's really what it is. If something bad happens, now it's my fault rather than something else. And I say minimal changes because we were kind of looking for things like network activity, file activity, host interactions, things like that. And most of the time, they don't actually change. They change little bits and pieces. But if we're going to get a little bit deeper into behaviors, think about a behavior like named vuln of the month, whatever it is. What is it this month?
I go up gigabyte.
It changes, right? It's but it's if this is actually probably something that could go back into SBOM instead of SBOBs. But just, hey, you have this list of potentially vulnerable open source in your software. You can just go and check, are you actually calling those functions? And that'll probably help you a lot, because there's a lot of vulnerable functions out there that you're not using. MD5 is technically a vulnerable function. It has collision problems, right? Triple DES exists in OpenSSL. This was actually something that somebody brought up to me recently, hey, triple DES is there. Oh no, you have a vulnerability. And you're I don't call it though, please stop. But the log4shell thing is actually something really interesting to me, because I had a friend working in security right around this time, and I was talking to him after the fact, and he's okay, we are not a Java shop whatsoever, but our insurance company called us and said, hey, did you make sure to mitigate log4shell in your app? He's it took me way too long to be able to just explain to them, it's fine. We don't do Java. It's not there. But it still wasted his time, right? And I think that's just one of the problems with trying to figure out vulnerabilities is you need to understand what is the software you're doing actually using. And here's an example that I found out of a vulnerable function that right here, it's X509 verify param added 0 policy. I found this on the OpenSSL website because I was reverse engineering something, and I was oh, this might be a good example. And this is actually the piece of malware that got embedded into PyTorch. So this particular function is only called, it's external, there's an indirection, there's data. It's not actually being called anywhere. So don't worry, if you have the PyTorch malware on your computer, you don't have to worry about this vulnerability. That's nice, right? 5 minutes, awesome. And then finally, ideally, from a malware analysis perspective, this is the thing people really care about for behaviors right now. If anyone's going to release malware into your environment, make sure they tell you what it's going to do beforehand. Okay. It would be kind of them, right? hey guys, it's all right. But this is the mainstay. Like this is the picture. I clipped this from VirusTotal. You can see here kpatch notepad.exe. This is an example my co-founder and I created of a backdoored bit of Notepad that pops calc. So you probably want to know if your Notepad is popping calc, right? The interesting aside is we uploaded this to VirusTotal, and that's why we have this information. Nobody caught it because it's really hard to find malware in trusted software, right? Even when it's doing something like popping calc when it shouldn't. But if you think about this, the attackers are really good, again, about getting around these things. So I don't know how much people really trust them implicitly. Even FireEye itself got compromised during the SolarWinds attack, right? And just my own experience trying to evade these kinds of things, it's not that hard. Especially when you're just like, hey, I just want to run this piece of malware. OK, well, it has a command line argument, and it won't run unless you have the right command line argument. OK, now you got to find that in order to run it to do your own malware RE. But if you can build these yourself, and do this, it's obviously going to be helpful with incident response and looking for similarities between different pieces of malware. So I guess we have 4 minutes left. So key takeaways. SBOMs are fine. We know SBOMs exist, but they don't give you the information you really need. The key problem is getting the information that developers themselves don't actually have. In talking with a lot of developers, I've said, oh, hey, if we said, hey, you have this behavior, would you know if it exists or not? And most of the time, the problem is when a cyber person is talking about behaviors, we're talking a little bit lower level than most developers care about. And not even just that, they might know the bits and pieces. So if we want to have, hey, tell us what MITRE ATT TTPs are like, what's a MITRE ATT TTP, right? The other problem is 90% of the time, 90% of the software is just open source, that they don't actually have the introspection that they need. So, I mean, when I build stuff, I'm not building stuff from scratch either, so I don't blame them for that. But we should be able to get this information because it will be useful. So as security teams, as developers, push to get these. Try to get it as part of tooling agreements. Try to baseline these things for yourself, because if you can do this, then you can hopefully make your life a lot easier. Because this is the kind of stuff you actually care about. Is this software going to do something bad? So I have 2 minutes. Any other questions? Or am I done? Yeah.
Yes, that sandboxing. I can recall there's one website. I can't remember what it's called, but all it did was just pretty much spin up a, I think it was a Windows XP, ran exe game. It was used for people who were saying like, oh, your program's so legit. Oh, watch this. Hey, look, it's doing that. It's doing that. It's doing that.
Yeah. So are you asking what website does that, or like?
I don't remember what it's called. But it's like kind of sandbox.
There's quite a few of them. I think there's Joe Sandbox. There's AnyRun. There's Cuckoo Sandbox, but I don't think that's been updated in years. Last I checked. I think it's open source though. You can go fork it and fix it. You have time for that, right? VirusTotal does some of this. So there's a lot of options if you're trying to do sandboxing. And there's other more. I think hybrid analysis, I think, is another one. I'm like just going stream of consciousness on potential things.
Sandboxing to like analyze behaviors by just watching them actually.
Well, right, that's the thing. And what's interesting, so one of the big problems there is it's going to show you one control flow, usually. If you do it in production, though, and if you're actually watching in production, then if somebody is interacting with the software, then you'll actually see a lot more behavioral paths. So that's another option if you can get the kind of like introspection you need for that.
I agree with this. This is awesome. I think one of the problems that I see with SBOMs is customers don't want them. They don't ask for them. And as a result, the engineering teams never want to provide them or really get on board. So it's like security is in the middle being like, no, guys, you really want this. And both sides are kind of like, eh. So, I mean, I love that you ended with, like, we have to start asking for this. But do you have any other thoughts about how, because SBOMs have been around forever, and people still, like, aren't there. So do you have any ideas about how you as a community can better influence the people communities that we're in to start, like, actually
There's two things. I mean, first, like, I don't think I said it, but in one of my go-throughs, I was just like, can we just please stop talking about SBOMs? Like, there's this kind of like baseline thing from a security perspective. I think the other thing is like, you have to think like the other person, right? You like, treat others like the way you would want to be treated. You want somebody to like think about, hey, from security, I care about security. Like, okay, well, what does the developer care about, right? And they care about streamlining their processes, right? They care about security not getting in the way. Oh, I have to stop talking apparently, but we can talk. Sorry, I've been ignoring her over here. But yeah, I think think about the other people and try to help them with their problems.